So in this video, we're going to get into the technicalities of how we know what common tones we'll have under transpositions. And as you can see here, we're going to be using an integral class vector to figure out what common tones we're going to get when we transpose a certain set. So the integral class vector of 047, we started with a C major triad. We were just transposing it back and forth. The integral class vector, if you remember, is 0, 0, 1, 1, 1, 0. And I'll remind you that that means that there's no half steps, no whole steps, one interval of 3 half steps, or a minor third. In the case of 047, between E and G, one interval of 4 half steps, or a major third from 0 to 4, of C to E, and one interval class of 5, which is here O to 7. If you remember, integral class can only be up to 6. It's the shortest path on the block face between O and 7. Between C and G, that's 5 half steps. So as you can see, what we saw earlier is that we got common tones under transpositions that correspond to these 3 interval classes. So when we transposed it 1, 2, 3 half steps, we got G. When we did 4 half steps, we got E. When we did 5 half steps, or 5 half step interval class, we got C, common tone C. So you can see that, at least in this example, and we'll see that that's true for any set, the integral class vector actually tells us, or can tell us, what common tones we'd have under transposition. Now, if you think about interval classes, each of them represents 2 optional directions. So if we actually, so if I look here, this would be T3 of C major, the C major triad, right? Make some space here. This would be T4 of C major, and this would be T5 of C major. You can probably guess that if we continued up, we'll find more. Here we have one common tone. It's a G. And this is, if we start from C, 1, 2, 3, 4, 5, 6, 7. So this is T7 of C major. And why does T7 work? Because the integral class that represents T7 is 5. So because we had 5 here in integral class, it also tells us that T7 will work. All the possible transpositions of a C major triad. And we can see again, we have this C here, the common tone, and that's T8 of C major. And 8 works because 4 and 8 are both integral class 4. And lastly, T9, which is the same as T10, integral class as T3. Once again, we have E as a common tone. So again, we can run this and say, let's transpose a T3, a T4, and a T5, and we get common tones at each one of them. At T3, 3, 7, 10, we got G. Now mathematically, this makes perfect sense because the integral class vector tells us there's one interval here that's a 3. Of course, if we add 3 to this number here, 4 plus 3 will give us 7 here. That will be the common tone. Again, mathematically, if we do T4 and we have a 4 interval from 0 to 4, we add 4 to 0, we get 4. That's the common tone. And lastly, if we add 5, 0 to 7 is integral class 5. So if we add 5 to 7, that's 12. Mod 12, that will give us 0. Same works for intervals 9, 8, and 7, because integral class 3 is 9, interclass 4 is 8, interclass 7 is 5. So let's see those again. These are the same chords we had in the Sibelius score here. You notice Music 21, when it thinks in interval classes and pitch classes, it does not actually spell the chords correctly, but that's a pretty cool feature actually to remind us that this will work for any set, regardless of its aesthetic or historic connotation. So it doesn't have to be a major or minor chord. This will work for any set.